Hello all and welcome to my YouTube channel. Welcome to the AutoGen series where we are learning AutoGen in depth. Now as you all know that AutoGen is a agentic framework which is developed by Microsoft and it is open source. So this is the 5th video in this particular series, and if you have missed out previous 4 videos, then what were you doing? Go ahead and check out those 4 videos and link is available in the description below. So in the last session, we have seen that how we can execute the code or how we can add a code execution functionality to the AutoGen agent, and we can add that functionality at agent level. And we have seen code execution on command line in our local environment. Now, in this particular session, we are going to cover a code execution using Docker. Now, why there is need to execute the code using Docker if we have the feasibility to execute the code in local environment? Now, whenever we are executing the code in local environment, there are several risks associated with it because your agents are having access to your local computer, and through that there are chances of data leakage. And in production environments or in development environment, in deployment environment, it is not recommended at all. That is one point. And also we need to make sure that whatever agents that are executing the code, they should have a feasibility to execute the similar code into the production or deployed environment. And in order to add that feasibility, we need to push our code we need to containerize our code using Docker, and that's how we can push it to the production environment. Now, we have seen the security concern, and that's where we are switching to the Docker. But let's understand a high level what Docker is. So this video is not related to the Docker, but I would really like to give you a very high level touch to the Docker so that there will not be any confusion. So let's understand what exactly Docker is. So Docker is a containerized application where it packages our code and push or ship that particular code into the deployment environment. And the reason why we need Docker is because it helps us doing the deployment hassle-free. So whenever we are creating a package file of our code, it makes sure that it covers all the environment related dependencies, and then once your code runs using Docker file in one environment, we no need to worry about other environments. Whatever will be the environment, it will make sure that the code runs smoothly in all the environments. And that's where whenever we are building a Docker file in local, that local Docker file, if the code is working in local, it will work in all the environments and will not face the issue where in the organization, there is a very popular say that the developer says that the code working in my machine and tester says that no, it's not working in my machine. That issue it solves. So this Docker is nothing but the containerized application. Let's say this is your container and it will have your image file. This is the Docker image. What this image contains is the code metadata. Code metadata, or we can call it as a blueprint. And once this Docker container is created, we can shift this particular container to the deployment environment. And that's how the hassle-free deployment happens in the organization. There are other advantages of it. Let's say with Docker, it is lightweight. Also, it is easy to share. And third, it maintains the consistent environment. So those are the advantages of Docker. And as we know that image is nothing but the replica, or we can call it as blueprint of our code. So basically this image will have all the information like what is the Python environment if you are using Python. What is the Python version. Then what is the code information like what are the files, modules, all that information it will have. Okay, enough of theory, and now what we can see is how we can execute the code with the help of agent using Docker. So let's jump onto the VS Code and see this practical stuff. Okay, so this is the environment in which we are working, and if you remember, we have built this code executor.ipynb last time. So in this series, in this lecture also, we will continue with the ipynb file. So let me go ahead and create the new file here, and I can say the file name as, I can give the file name as docker code execute.ipynb. Okay, so the file is created. Let me select the kernel. So this is our kernel, Python 3.11 virtual environment. Now let's get started. First of all, what we need to do is we need to import the dependencies. So we need sys os temp file just like we used last time. This temp file is required to store your output data. Whatever be the result generated by code, it will save into this particular location, and then the conversable agent. So let's import that. Now another thing what we will need is the Docker command line executor. So if you remember last time, here we have used local command line executor, and now we will need a Docker line command executor. So let's execute that, and let's define the temporary directory and executor part. So everything will remain same. It just now you can see the temp file or temp directory we have defined, that's the default directory. And then in executor, instead of command line executor, we are calling Docker command line executor. And here we are passing image, timeout time, and work directory. These two parameters are similar to the last one. This is the new image. So as we saw in the theory, Docker requires the image. This image is nothing but the base replica of your Docker image. Of your Docker. So this is the particular Python 3.12 Slim is a image that is already Dockerized, and we can directly reuse this particular image. So this provides us a platform to run the code. So 3.12 environment is already available with the help of this particular image, and we'll be able to use that. Now, in order to execute this particular code, what you will need is you will have to start your Docker container first. And to start the Docker container, if it is not installed in your machine, you need to install the Docker container. So you can see it is taking some time. Let's see. Okay, so the code execution is done. It's because earlier I have tried, and that's where my Docker was open. So that's where it has executed the code. But for you, it may fail. And if it is failing, what you need to do is you need to install the Docker. For Docker installation, I'll add the Docker installation link in the description. You can go through that process, and it's very simple installation. You can install the Docker based on your OS system. So this is the particular link which is available. You can go ahead with this particular link and you will be able to install. This is for Windows, but all other details are also available. You can see Mac and other details are here. So you can do the installation. Just let me know if you face any issue in the comment. If you are not able to install Docker, or if you are facing any issues, I will prepare a separate video for that. But just to save the time, I would like to continue. So what now I am going to do is I am going to open my Docker. So you can see this is the Docker desktop that I have installed. So let me open that, and let me show you. Currently there will not be any image. So whenever we will execute the code, it will create this Python 3.12 Slim image. Okay, so you can see this is the Docker desktop that I have opened. So currently in the containers, we don't have anything. And in the images, let me clear this because I executed the code. So it has created. So, okay, so I have cleared all the previous images. Now let's go ahead and run this particular step. So whenever we are running, it will create this particular image into the Docker. So basically this image is already available on Docker website. It will download this image, and that's where it will create this 3.12 environment for us. So this will take some time for execution. So let's wait for that. Okay, as you can see, the execution is completed. So let me show you the Docker. So you can see under the images, you can see this is the Python image that it has created, and you can see 3.12 Slim. So this image it has downloaded, and for downloading, you can see it is worth 125. You can see it is 124 MB image in size. That's where it took some time to load that particular image, and this is the container. So now what we can do is we can close this. We just need to keep this open for further code execution. So let's add further code. So as we have added executor, so it's time to add the code execution agent. So we are writing code executor agent using Docker, and we are calling conversable agent, the same class we are calling from AutoGen. And this is the name of our agent. And LLM config, currently we are not passing any LLM config because this is code executor. It will only execute the code. And as I mentioned in the last video, where we passed the code manually, and I mentioned that we can also pass the we can also have another agent to generate the code. So in this particular video, we'll have one agent to generate the code and this code executor agent to execute that code. So this is the first executor code that we have written. So let's execute that. Now it's time to write the coder agent. And for coder agent, we need to write a prompt. So this is the prompt that we are giving. As I mentioned last time, we directly pass the code, but in this particular, we want a agent to generate the code, and that's where we need to be very mindful, and that's where we have added all the instructions to generate the code. So it's responsible for generating a Python code. And let's define the Python code generator agent. Yeah, so this is our code writer agent, where we are passing conversable agent, the code writer agent, and here we are using system message as this particular message, the LLM configuration we are defining, and the code execution config. Code execution config, we are passing it as 4 because we don't want this particular agent to execute the code, and instead we want the code executor agent using Docker to execute the code. So this LLM config we need to define, because here we will need a LLM to generate the code. And let's add the LLM configuration. To add the LLM configuration, so if you remember, we have already created this LLM config.py file, and from where in this particular file we are using the Azure OpenAI to load the GPT-4 model that we have deployed on Azure OpenAI service. So if you haven't really watched that particular video, I have covered that into the first video of this particular series. So go ahead and watch that video, where you will find the details how we can create a Azure resource, OpenAI resource, and how we can deploy a GPT-4 model there. Or else you can use this particular LLM configuration if you already have a Azure OpenAI, if you already have a OpenAI subscription. So if you directly have that, then you can directly pass the model API key from the OpenAI API key, and you can use this particular code. But yeah, as we have deployed the LLM on Azure OpenAI, so we'll be using this particular config. So let's call this particular config into the Docker code execution. So for doing that, so currently if you can see, this Docker file is inside the code executor. So we need to go one step back at this level, code execution path level, and then from there we can access this particular config file. And in order to do that, what we can do is we can add a system path. With the help of sys, we can switch to one step back. So this dot meaning we are switching one step back, and then from LLM config we can import the LLM config. So let's execute that. Yeah, it is successful. So we are able to import the LLM config. Let me show you that. Yeah, you can see it has extracted the LLM config. So let's execute this particular code. Now both the agents are done. The code executor agent is also done, and the code writer agent is also completed. Let me show you this, how exactly the Docker installation will work. So this is how we are building now. So first we have built the code writer agent, which is the LLM, and where we have given LLM feasibility because we have passed the LLM config, which will message with code block. So it will generate the code and pass that code to code executor agent, which is in the environment of Docker, and then it will execute the code and sends the response back with the output to the code writer agent. And this particular code executor agent, let's dig into that particular agent. So this message with code block, you can see this one, it will be passed from the LLM application, and then LLM agent, and then it will pass to the agent code executor. Agent code executor will write a code file, and that file it will execute into the console output, and everything will happen in the Docker container, and then it will create that output back to the code executor, and code executor will return the final output. So that's how it will happen, and this is local operating system, so that output will be saved into your local temporary path. So that's how the code execution with Docker will work. So let's jump onto the code again, and now it's time to call these agents and perform a task. So let's do a first task where we are calling code executor agent using Docker, and we are initiating the chat, and then we are initiating a chat with code writer agent. And for code writer agent, we are asking to write a Python code to calculate 14th Fibonacci series or 14th Fibonacci number. So let's see what it does. Okay, you can see the conversation now. So initially it has started code executor to code writer agent. It says write a Python code to calculate 14th Fibonacci number, and then code writer agent had written this particular code. You can see it is in Python. Last time, if you remember, we passed this code manually, but now this particular agent is generating this particular code, and then it is calling that particular function, and then it is asking the code executor to run this particular code in Python environment, and then this code executor is executing that, and it has returning the output. So you can see it has returned the output as 233, and then this particular code agent is asking to terminate the response because it has generated the response, so it has terminated, and then the chat is terminated. So why the chat is terminated? Because code executor agent with Docker met the termination condition, but you will not see that condition available in the code executor agent with Docker, and it's because, if you remember, we have covered this in our second video where we have learned the termination part, how the agent conversation terminates. If you are not passing any termination criteria, then it picks up the default criteria as termination. So basically there is one parameter that we need to pass is termination flag equals to terminate. So it is using that particular flag, and that's how it has terminated. So let's see one more bit complex example. Okay, so in this particular example, what we are calling is, or what we are requesting the code writer agent to write a Python code to line chart, and we are requesting the agent to assume some data and save the plot with the file name as linechart.png, and also we are requesting to install the required dependencies if there are not. So let's execute this particular code. Now in this particular thing, what will happen is it will install the dependencies into the Python environment that we have used under the Docker. So we have used Python image of 3.12 Slim. So it will do the installation at that particular environment, and it will execute the code. Now there is no direct link to your local connectors or your local command line. That's where now your environment is safe. You are not using the local environment, and everything, whatever installation, whatever execution is happening, it is happening on the Docker file. Okay, so let me expand the conversation. So you can see the conversation is going on. So the code executor to code writer, this particular question that we have given, then it has started noting the points, and it has started writing the code. So you can see also it has started, also it has written the code to install the dependencies as well. You can see it is passing the commands to execute the file. So it has created this particular code file, plotlinechart.py, the one that we have seen in this particular nodes. So this particular code file, it has created that code file by its own, and now it is executing that particular code file. You can see it is failing with several dependencies. It is saying that, okay, module name numpy is not available. So our agents are suggesting to install the dependencies by its own. You can see it is saying that install matplotlib and numpy. So this code writer agent is taking care of everything. It is requesting to install the dependencies as well. And once the dependencies are installed, then it will execute the Python file, and then it will save the results with this particular file name, linechart.png. Okay, you can see it is saying that this linechart.png file is successfully created without limitations, and then it is saying terminate. So everything is terminated. So let's say whether this file is available in that particular directory or not. So in order to check that, our local path where it is saving the file is this particular path, right? So let's write a small code to plot that particular file or load that particular file. So with the help of IPython display, this image class, we can load the image. So the image is available in the directory.name, and this is the name of file. So we can plot this. Okay, so you can see the linechart.png is plotted. So this particular file is available at this particular location, and it has plotted this particular file. So isn't it interesting? So it has used Docker as an environment to execute the code, and it has saved the results into the local. Now you can save the results at your default location wherever you want, or at your custom location. So yeah, that's how we can use the Docker in order to execute the code using our AutoGen agents. And this will be very helpful whenever you are planning to deploy your code into the production. I hope it was a very good learning for you. This particular code is already available in the GitHub link that I have provided into the description. So please go ahead and clone that particular repo and practice this stuff. So whenever you will practice, you will get better understanding of this particular AutoGen agents. And apart from that, if you really want to, or if you are interested in learning a building generative AI applications using Azure OpenAI services, then I have prepared a separate course on that. You can check out that course. The course is available on Udemy. You can check out that particular course, and the link is again available in the description. Please go ahead and check out that particular course. So thank you so much. I hope you learn a lot in this particular session. And if you really like this particular video, please go ahead and like the video, subscribe to my YouTube channel, and I will see you soon in the next video. Thank you so much.